This will be an example of writing an equation from a table where we are looking specifically at writing a logistic equation. We're going to take the problem that we were working on in class, which started with a development that had 1,000 houses in it. So that's how many are available. We have a table of the sales based on the number of months that have passed and how many homes have actually sold. In order to do this equation, we need to know what the logistic equation is. For this particular example, since we're talking about individual houses, we will be using a discrete version, which is y equals c over 1 plus ab to the negative x, where in this logistic equation, c represents that maximum value. In order to solve this and figure out what the actual equation is, we're going to need to figure out what A and B are. C we already know because that's the maximum number of houses available, and that's 1,000. So we have two variables that we're trying to figure out, and that means we will need two equations to solve a system of equations with these. So the first thing I'm going to do is I'm going to pick two of the data points, and especially for a problem like this, I recommend choosing the two extreme points. Okay, so let's start filling in what we know. We know that if we've sold 103 houses, that has taken place over 2 months. Now we'll write the second equation and fill in the same pieces of information. We know the maximum is 1,000. We're looking at when we've sold 167, which is after 10 months. In order to solve for A and B, I'm going to need to bring these equations together some way such that I get a single equation with only one variable in it. What I'm going to do is I'm going to take both of these and get them out of fraction form. So I want to get this A and the B up into the top part of my equation. And the way to do that is to multiply both sides of the equation by the denominator. The 1 plus AB to the negative 2 for the first one. And for the second one, it's 1 plus AB to the negative 10. On both sides. This way that'll divide out on those two sides, leaving me with just the 1,000 for that next line. So that gives me, when I distribute my numbers, 103 plus 103 AB to the negative 2 equals 1,000. And for the second one, 167 plus 167 AB to the negative 10 also equals 1,000. I mentioned before that my goal is to bring these two equations into a single equation. Since the variables are multiplied together, I'm actually going to need to divide these equations to get rid of one of those variables. In order to do that, I need to get it to a place where the A and the B are left alone on that side. So first thing I'm going to do is subtract 103 from the top and subtract 167 from the bottom, leaving me with 103 AB to the negative 2 equals 897. And for the bottom one, 167 AB to the negative 10 equals 833. Now I've got my two equations. I've got my parts where the A and B and all the multiplication stuff is on the same side. If I wanted to at this point, I could divide both sides by 103 for that one and 167 for that one. I'm not going to do that because that's going to make the right side of my equation complicated. I'm just going to go right ahead and divide these two right here. Just like that. I'm not going to touch my calculator yet. I'm going to save that for a couple lines down. Doing this division, I now have 103 over 167. The a's divide out, leaving me with b to the negative 2 over b to the negative 10 equals 897 over 833. I'm going to start simplifying this a little bit. I'm going to write the number part of this as a separate fraction. And that gives me b to the negative 2 over b to the negative 10. Remembering my rules of exponents, when I have bases that are divided, I can actually take the exponents and subtract them. So I'm going to do negative 2 minus negative 10. And that's going to give me 103 over 167 times b to the positive 8 equals 897 over 833. Before I can solve for b, I need to get the b all alone now. So this is where I'm going to do my next step of getting this 103 over 167 out of here and move it to the other side. I'm just going to multiply by the reciprocal so that on the left side I get 1, and on the right side I am going to get a very large pair of numbers, giving me b to the 8th equals 897, 149799 over, oops, this is 103, sorry about that. Eight, 5, 7, 9, 9. Big numbers, but I don't care because I'm going to let the calculator do my work for me. When I've got this now, I've got b to the 8th power equals some number. I can actually take the 8th root of both sides of this equation now. And when I do that, that's going to give me a value for b. I'm just going to punch all of that into my calculator. Do the 1499799 divided by the 85,000 number, and then I'm going to take this, the 8th root of that answer, which gives me approximately 1.721. And then there's a bunch of numbers after that. I'm just going to go out to this place and round to that number. Now I have a nice, well, messy, but nice approximation for b. Now that I have that, my next step is going to be to figure out what a is. So I can take this b value and go back up to one of these two equations and plug that b value in there and then solve for a. So I'm going to use the one that has the slightly smaller numbers just to make my life a little bit easier. So we're moving on to, let's do this. 103 plus 103a times that b value, 1.0721. That's raised to the negative 2 equals 1,000. Subtract the 103. Get gets me to 103 times a times 1.0721 to the negative 2 equals 897. Divide by 103. A times, and if you want, you can punch this into your calculator. And we get a decimal of about 0.870. Since I'm in the midst of this part of the problem, I could probably just leave that as a rounded number. And 897 divided by 103 is about 8.7087. Divide by this number. On both sides. The A is about 10.01. We now have our A and our B values, so we can go back to our original equation and plug those in. So y equals that maximum value of 1,000, 1 plus 10.01 times 1.721 to the negative x. And there we have our equation.